Welcome. This is a video to introduce you to Statypus, a free and easy access website built by Dr. Phil Hewling. Technically, we're discussing the website r.statypus.org. This is a website that was built for student use. It's built with and meant to work pretty much solely with the software R and RStudio. This document will change over time with corrections, as I'll mention later how to point out any errors you find to the author, as well as additions that may be made to the textbook. However, you will always know how recent your version is by looking at the landing page. Here we see 2025-08-19, which means the version I'm looking at was last modified on the 19th of August, 2025. There are a few options we have available to us on this landing page. The A here is our text options. Clicking the big A makes the text bigger. Clicking the little a makes text smaller. You can do this to your own satisfaction. There are limits, however. We do have two font options, the default being the displayed sans. You can also choose the serif, which is a little bit different feel if that is preferable to you. I'll switch back to sans. The book was designed to be optimized around the white format, which is dark or black text on a white background. However, if you prefer, sometimes in night mode is better at night if you want a lower light setting in your room. In between, in a certain sense, is the sepia, which has a little bit of a nostalgic paper look in some cases. I'm going to navigate back to the white and navigate from there. Another thing we see here is the table of contents button, this button right here. If I see the sidebar table of contents, clicking that will remove it. If I don't see it, clicking it will bring it to the fruition. I can also use this to navigate the textbook. For example, I can go into chapter 5, section 5.4, even into the subsection level 5.4.2. Within the textbook, you will find other ways to navigate around. For example, here you see a link which is shown by the blue text of section 5.4.1. If I hover my mouse over it, it does look like a link. Clicking on that will take me to section 5.4.1. Other things you can do is navigate through certain types of objects within the book. For example, inside example 5.11, which is Toy Cars Part 2, there's a link to example 5.6. Clicking on that brings up example 5.6, which is Toy Cars Part 1. This discusses a data set which you can look at more if you wish to. Okay. Other things we have here is we can look at YouTube videos. Let me go into section 6.3 and scroll up a bit. This is a video that was meant to walk through the solution of the problem posted here. You can click on this. And if the audio didn't work, I do apologize, but this is meant to be shown directly in your browser. You don't have to leave the website. You can hit the YouTube button to pull you into the main YouTube channel, the main YouTube URL if you wish. You can also watch it directly in here. Now, besides the ones produced by Dr. Phil for Statypus, there are other professional ones. One I'll point out to you here is here in section 10.1. This is produced by 3 Blue 1 Brown. He's probably the premier math visualization YouTuber, and this is his take on the central limit theorem. Other things we definitely use in this textbook are Desmos explorations. Looking at this one in section 7.6, we see a static image discussing the empirical rule, sometimes called the 68, 95, 99.7 rule. To show why that's true, I'll turn on the dynamic mode and show that between z is -1 and +1, I see 68% of values. If I go between -2 and +2, I see 95% of values. Between -3 and +3, 99.7% of values. I could also ask questions like what happens if z is between -2 and 0. It gives us a value of 47.5%. Also take a second to apologize. You hear any awkward sounds in the background. I do have 2 pups and they are enjoying their day home with their father. Right. Now, other ones we look at, a little bit more statistical interactiveness here. This is looking at flipping a coin 50 times and seeing how many times it turns up heads. This does it 10 times. This says that one time hit 19, knowing it's just left of 20. One time hit 21. It looks like it had 22 heads twice. Got 24 heads once. It got 25 heads twice, so on and so forth. I can increase the number of things, and if you crank it up, you might start seeing a bell curve we just looked at. We also have more advanced tools, which we can look at here. Probably getting, let's say, between 19 and 23 heads. Here is 329 times out of 1,000. That's 1,000 times. The coin was flipped 50 times, and it got between 19 and 23 inclusive 329 out of 1,000 times, or 32.9%. You can randomize that and see that it's always going to be a little bit different because we're looking at random situations here, but it's always near that 30-ish%. We can look at exact techniques in the book for exact answers, but for now, the simple way of playing with it. This is meant to really make you dare to ask your teacher or other instructors or anyone more questions. Don't feel like you're constrained to what's in the textbook. Always be willing to ask, but what about if I went a little bit further, did something a little bit different, or asked a little bit harder question? Please use these as other things to do that as well. Now, one of the biggest features of Statypus will be that we can use it to get code out to run inside our computer. For example, looking at section 6.1, here's a data set about pigs. This is based off the Pass the Pigs board game, or sorry, game, I should say. If I put my cursor over that and I click on this little thing here, which is the copy to clipboard, I can then navigate over to my RStudio. Here's what I would call a clean install of RStudio. There is nothing in the environment. There's nothing in the plots. There's not even a fourth panel. Now, to get the fourth panel, I can click this little button here, bringing up my window here. If I pasted that in. If I hit hold control, hit enter, it'll run it in the console, which brings into my computer right from the website 5,977 observations of 5 different variables. It's now ready to be used in my computer. To show an example of how to run information with that code, I'm going to scroll down here a little bit. Oops, I think a little bit too far. No, right here. So here are the different options that come from rolling a pig die. To show what that looks like, I'm going to run that here. This shows the probability of getting a dot down result on a pig is 34.52%, dot up is 30.05%, so on and so forth. So I'm getting the code run right in my computer by simply copying it from RStudio and moving it over. Now, another thing that we'll do here is showing how we can make certain limitations be improved. For example, RStudio is not good at giving histograms of discrete data. To show that to you, I'm going to copy in this code template from section 3.3. I'm going to insert that into my RStudio. I'm going to take out the generic X and input the data as mtcars $carb. This is the number of carburetors in the cars in the mtcars data set. Running that inputs data into my machine. I'll change bandwidth to 1. It could be any integer you wish, or I should say any positive integer you wish. And if I run either line 7 or 8, it should give the histogram over here. We see 7 instances where I had 1 carburetor, 10 instances where I had 2 carburetors, 3 instances where I had 3 carburetors, and 10 instances where I had 4 carburetors. To show why we use this fancy code, not something I will type in hist of mtcars $carb. Running that, you notice a much different situation pops up. I do see 10 and 3, however, I see 17 in this first bin. Unfortunately, it doesn't handle discrete data quite perfectly. It's combined the 7 of 1 carburetor and the 10 for 2 carburetors into this one block, which is 17 high. Notice I also use the back and left arrows here to navigate through the different plots I have created within my RStudio. Okay, so perfect. Now I will mention that all the functions here are meant to work on a clean install. The few exceptions to that rule, there are a few functions we built at Statypus to help make certain things easier for you. For example, if I go to 5.4.2 again, we looked at this section earlier, we navigated away from it. However, if you wanted to use the function linear regression, I would have to first load it. This is not built into RStudio. This is a Statypus original function as it says here. Clicking here brings me to the appendix of chapter 5, which has the information needed. We'll see this long box here that has all the gory code for this function. If I clip on the clipboard function here, you could run it in the script. You could also put it straight in the console. I recommend this for things you're actually running, but just to input functions, we can do it. So I'm going to copy it in there. I'm then going to run that. I now have the function in my environment, linear regression. To show an example of that, look at the linear regression. I'll put x equals nt cars $displacement, which is the displacement of the internal combustion engine, and y equals nt cars $weight, which is the weight of the vehicle. Showing that, we get a graph of the scatter plot, x along here being the displacement of the engine, y being the weight. I see the dots on the scatter plot. It gives me the least squares regression line. It gives me the equation of the least squares regression line. You state it in the form y hat equals a plus bx. It gives me the correlation, the intercept, which is the value of a, and it gives me the slope, which is the value of b. Now, this can all be done with base R code, but to get something like this require quite a few different button presses. This is meant to be a one-stop shop for looking at linear regressions. Navigating back, if I want to get back to where I was, I mentioned here I can hit the back arrow. That brings me right back to where I was. And if I go back into section 5.1, sorry, 5.1, I'm going to scroll up a little bit to show another thing that's in the textbook. This is one thing you can look at if you're looking for really interesting and small details, or just something the author thought was interesting. You will see footnotes from time to time. Clicking on those, for example, brings you to the bottom of the page for those. This is talking about the discrepancy or the non-differentiation between mass and weight. A pet peeve of the author. I won't go into much more of it here. So if you wanted to read information about that, you could look at the information here. When you get right back to where you were, you can either use the back button or use the little button right here, which takes me right back to where I was in the textbook. Okay, we're almost at the end here. I mentioned earlier about mistakes. If you were to find any mistake in this textbook, I absolutely encourage you to reach out to me to let me know. You can report those by scrolling on the welcome page, either found by welcome or R is for stats. Scrolling down till you see the remark. You'll see report any errors found on the site here. Clicking that link should bring us to a Google form. Describe the error as much as you can here, and then at least in courses I teach, you can get extra credit for that as well. You can put your contact information here and the mistake you found right there. I mentioned here, this is simply showing my email account because I'm citing the Google Docs. You don't have to have that. Again, I can navigate back. If you find other mistakes or other major issues you'd like to discuss, you're welcome to contact the author directly at the email, which is right above that remark. Again, my name is Dr. Phil Huling. My email address is phil.huling@slu.edu. I thank you for coming. I hope this book is beneficial to you. If you have any questions, please reach out.